Welcome everyone. I welcome you with these nice flowers. Whenever we see the flowers, that will take our attention, definitely. There is no doubt, because that is takes our attention with a nice attractive color and makes our mind more happy. So in that way, why the flowers are more beautiful? For that we need to know one basic physics. That physics is whatever the material, the light will fall on it will be all the colors. That means all the frequency of light will fall on the material, but it will emit on that particular color which we are seeing the material that reflects that. If there is a white color material, then it is reflecting all the colors are falling on it. If it is some red color, then the material will absorb all the light falling on it, but only emit the frequency of the red color. Like that, these flowers also will do the same thing. It will receive all the colors, but it will reflect the best color out of it. So it's like our example. We can receive all the knowledge, all the information which is getting to ourselves. Same way we have to we cannot reflect everything, but we have to do analyze and get the good things, and we have to reflect the best of it. So then we will be more attractive, more will get the will be a best fellow with respect to everyone. So this is the note I try to share with you. With this we will go our normal class. So today just I am going to introduce the syllabus first unit. The first unit of the syllabus is the properties of matter. When we are talking about the properties of matter, this is contain all the type of properties like liquid property or any electrical property or mechanical property or optical property. Like that the properties will be differ, but in our constraint to our subject, here we are going to see more of mechanical properties. One of the mechanical properties is elasticity. That elasticity and that is related with the application of stress and how it is reacting to that stress. It is getting strained, or strain is staying, or it is remain to the original shape. Like that we are going to study, and what are the effects going to make on that material and elastic properties. Those things we are going to study something about that. And then different type of elasticities are there. Like elastic modulus are different types are there, like linear elastic modulus, that is Young's modulus, or rigidity modulus. That rigidity modulus will come in terms of torsional stress. When applied torsional stress, that will take rigid rotations, that will be called a twisting couple, how much twist it is taken because of the torsional type. So those things will be seen in that portion. That portion contains one torsional pendulum experiment and the theory. Those things we will see in class as well as lab also. Then bending of beams, like how when we go to bending of the beams, that one of the best example is cantilever. A cantilever is like an example for the bending. Okay, how it is bends, that because of the external application of the force that makes. So that is two experiments are there, like uniform and non-uniform bending. That experiment and the theory will be studied here in this first chapter. Then one of the example of this cantilever and the beams are eye-shaped girders, that we will see it in more of in the building constructions, that shapes will be eye-shaped. Those things are in the applications also. The understanding will go to be in the application of eye-shaped girders. Whatever we learned in the cantilevers and uniform bending and that beams, that will help us to make some nice eye-shaped girders applications. And then the bending stresses due to the bending in beams, those things are covered in the first units. So first thing we will see it as elasticity. What is mean by elasticity is, when we apply the external deforming force, the material will regain its original shape, and also it will reply that oppose the external force. So that that property is actually elasticity. If you read that, the property of the body which oppose the external deforming force and also regain its original shape and size after the removal of deformation force, that is called elasticity. That particular body is elastic body. So if you see some examples, we see some elastic material, and so see this nice image will show that some elastic body, that kind of animation they did. You can get the example of it. Like that you have seen in your lifetime so many elastic bodies like a rubber, so many other things, but more of elastic body is compared to rubber or steel, then steel is the elastic body, because that will take so much of stress than a rubber. Opposite to elasticity is plasticity. That means if I apply the external force, the deformation will take place in the material, but it cannot bring back to the original shape. That type of material, that type of body is plastic body, and that property is plasticity. Like our plastics day-to-day life use. That means plastic means that if you apply external force, then that will not go back to its original shape, it will remain at that shape. So both the properties are useful when we study about, then we are making a material, we should know the knowledge of both the things, how far it will be elastic and how far it will go, how far it will be plastic. Because if we want to change the shape of the material, then we need a plastic type of material, then only we can construction field and all, we can use only the plastic shape. Plastic, it has to change its original shape by applying the force. Though thus the elasticity also important, and plasticity also, those property also important. The same material, like a brittle material only will be elastic. When I try to take a scale, a meter scale, if I try to break it, what happens is it will start to bend sometime, and if I apply external complete force, it will bend, it will collapse. But in case of if a simple rod, steel rod, what happens is it will bend sometime, it will go back, but at some extension of external more of stress, then it will bend. That things also will taken place. So like it will act in initial stress level, it will be elastic. Over the limit, particular limit, elastic limit, it will go back to, it will go to the plastic region. So that things will be studied here as a how much stress we are applying, and because of the stress, what is stress is actually the restoring force per unit area inside the body is defined. The means from the body it is given the restoring force because of the opposition to the external force or deforming force. Either I can call it as deforming force or restoring force, both are equal. Restoring force are equal to deforming force. So this is in equations, it will be equal to stress equal to deforming force divided by area. The unit is Newton per meter square. Okay, such that we can get the equation for stress. Stress means actually the force per unit area. In other words, stress sometime will be called pressure. In 3-dimensional, it will be called as a pressure. Pressure will be more of talking in the case of gas molecules. But in materials, it will be called as mostly named as stress. Then another thing, because of the stress applied on the material, there is a change in the material shape. There is a change in shape and the dimension on the material, that will be calculated as a strain, that will be measured as change in dimension divided by original dimension. How much changes happened divided by the original dimension, that will be measured in strain. So 3 types of stresses are there. One is linear strain and shearing and volume. So you can understand like this is linear means one dimensional longitudinal. So only one direction force is applied, either direction one dimension only applied. And then here in the shearing, it is like in a surface, because one surface it is applied, another surface fixed to the ground. Top surface if it is applied, then top surface is taken. The shearing angled stress, tangential stress. And the volume or bulk stress. The volume means the complete all the directions, all the dimension, the force is applied or stress is applied. So if it is so, that 3 dimension, there is similar to the stresses, we have 3 types of strains. When it is a linear stress, then there will be a linear strain. When there is a shearing stress, then there is a shearing strain. Bulk stress, then there is a bulk strain. So there is a mistake in written. This is a bulk strain. Here elastic limit. So as earlier I mentioned, there will be elastic limit. That means the material up to some stress, that will act as a elastic body, then it will go to the elastic plastic region. But within the elastic limit, that means up to some stress, the material will come back to its original shape, then that is elastic limit. The maximum stress up to which a body exceeds the property of elasticity is called elastic limit or limit of elasticity. This will be more defined by this Hooke's law. The Hooke's law states that up to some stress, the strain will be proportional. That means how much stress you are applying, equivalent to the equivalent strain happens in the material. Like if I apply some stress on this body with this small weight, it is taken some amount of strain, and increasing the stress, then again there is increasing the stress, again there is increasing the strain. So but if I remove all these things, it will come back to this original shape. Like that you can get it. And then this proportionality constant is actually modulus of elasticity. The proportionality constant actually modulus of elasticity. This modulus only we are naming it as Young's modulus, and rigidity or shearing modulus, volume or bulk modulus. Okay, this way we have an idea what stress means, what strain means. So for that we had a diagram example. This is a simple diagram of a ductile material. One of the example is like a carbon steel. So this is an example of some carbon steel experiment result. So let's consider a wire, a steel wire of uniform cross sectional area. And it has to going to keep it in some stress application. So we will consider some kind of steel rod. So that has been fixed in the slab, and so weight and stress will be added to this steel rod. So this will be weight added to this here setup. So this will be, this is a sample. What happens to this sample with respect to stress as diagrammed here, graph we put it here. So that stress will be actually some points will be taken to consider. Those points are like the first point A up to O2A. This is elastic region. Elastic region. So elastic region means whatever the stress applied to this level, so up to this point stress, this material will come back to its original shape and size. That is the elastic region mean. This A bar will be the limit of elasticity. Limit of elasticity. Then another point here is B. That point B is yield point. What yield point will do is when the stress level is increased, so what it means, limit of elasticity is over, then that will be, then no more it is a linear. Linear means that is straight line, but after that it is taking some non-linear shape. In this shape it is explained like what happens is if I taken if I increase the stress above this A dash, then this will go to yield point. This yield point means once I taken the material to this point, it will not come back to its original point O. Instead it will come to P. It will get back to this point P. Okay, so this is this 0 to O to P, that point is permanent set. Permanent set means there will be a change once I taken, this is considered our A. Up to A region this material will be same, the cross sectional area will not change. If it is extension also, that will come back to its original shape. But when I taken to B, then small neck will be created in the shape. The cross section area in the material will be taken reduced. Okay, so like that point is whatever the extension it is taken, it will not come back. That also in the point B. So increased length will not go, it will not reduce after B. Okay, that is point is yield point. That yield point means the material will not get back to its original place. This region actually the plastic region up to this region, it is elastic region. Over that, this material become a plastic region. So I have written PR, that is plastic region. Once it is yield point, then it will go to maximum stress. This point is tensile strength. The maximum tensile strength is this much only. So what it means actually is the maximum stress this material can accommodate. Once it is going to this level, the bigger level of, once it is increasing over that level C, then higher level of neck is created on the sample. So the neck will be more. The bend what happens is completely is going to break. The strength will be reducing after this. After this tensile strength maximum, this material will go to be failure condition. This D point is breaking point. Breaking point. Okay, these are the status. So this is in B, this is in over after C. This is after C, the neck will be increasing after C. When it comes to D, the material will be broken. The neck will be extended and it will be completely failure. The sample will be failure. It is at D condition. At point D, the material will be broken. This is the breaking point. So these are the 5 points to be concluded. That first region is Hooke's region. Hooke's law followed region is elastic region and A dash. So what this stress strain diagram will explain to us, the material, some kind of wire or steel wire or some any cross sectional area material will go under this testing. Then we can get the points like how much it is elastic strength, how much it is we can understand, and then we'll go further and we'll get this tensile strength point. So tensile strength point will be used in material. So tensile strength can be written like in equation maximum tensile stress applied divided by the original cross sectional area. Area we can see. So this is actually tensile strength. So maximum strength, maximum stress applied on it, applied divided by original cross sectional area. And one more thing is that safety factor. When we go, why we are doing this testing and all, because we need to know how much this material can sustain for the applications. So when come to application, then safety factor is very important. That is simple tensile strength. So the particular strength will be there divided by working stress. So what is our application? Based on that, how much maximum tensile strength material can have, but working stress should be minimum, so that lifetime and their failure and everything can be measured. So from this stress strain curve, the uses are the first use will be, we know that elastic limit of the material, because different we can do for this testing to all the materials, elastic limit or elastic strength and ultimate tensile strength and all can be measured. And then this can be used to understand how much lifetime and given lifetime of material property like safety conditions and all can be measured. Safety conditions can be measured from the material. So similar way, this will be a basic testing method. It can be extended some else or more of it. So one of the thing is that when comes to safety factor, how that different material will be working. When it is a steel type of material, the safety factor value will be nearly 4, because 4 times less to be working stress. But when it comes to brittle type of material like a steel, the working safety factor will be 4. When it is a brittle type of like a brick or some kind of structure, then the working safety factor will be nearly 10. Okay, so what are the application? Then accordingly we can change our safety factor limits. So for maximum utility we can find it. And one more thing, one more application of the stress strain diagram is that if it is comes to elastic limit, then we can able to alter the shape of the material, or how much elastic stress it can sustain. In that particular limit we can change. If I want like a plate shape of this rod, then I have to apply more stress to make like a plate. So that kind of changes we can make it. So that is also one of the applications. These are the stress strain diagram and their understanding. So this is one of the useful idea for the basic level of understanding this understanding about the materials in the mechanical properties. Okay, then what are the factors can be affected by this materials, this tensile strength and the elastic modulus, how they will change, what are the factors will affect elastic region, the material can be modified. So what are the factors can affect this elastic modulus or tensile strength of the material, or we can see here. And the first one is there is a 5 types of affecting factors. So one of the affecting factor is stress. So as we seen in the stress strain diagram, so some particular region after the elastic region, there will be a change can be happen in the material by applying the more stress. So constant application of the stress on the body will change the body shape. So that will also affect the elastic property of the material. So that way, if it is more thin, that elastic property will be different. If it is more thick, then elastic limit will be there different. So the stress will affect the elastic modulus and their strength. And then the temperature, effect of temperature. If I put it in more hot region or more cold region, and the different conditions will change the elastic property of the material. So some material will be more brittle when it is taken to cold places. So that time that can easily break. Like kind of things, that elastic property will be changing because of the temperature. And then impurities. So when it comes to some material, they will not be more harder, like more so if it is taken gold, pure gold, that cannot be easily make as ornaments. But when it comes to added some kind of impurities like copper or something, some amount of impurities, very less amount, then it will change that property. So we can alter that elastic modulus, those things and all will be changed by applying the impurities. Those are the examples. And then other things are like work, hammering, rolling, annealing, those things also will change. Like when we do that, bigger size of grains will have less elasticity, brittleness. When it goes to smaller size of grains, then it will be more of elastic, more Young's modulus will be there, material will be high strength. Like that we can modify their modulus. So that is the examples, like hammering, or in case of rolling, annealing. Annealing is actually heating and cooling at the same time. Heating, we will heat it high temperature and we will cold it to very quickly, like with ice water or something, like a water cooling, like that we will do, and that will be changing the modulus of the material. And nature, crystalline nature, that means if it is a polycrystalline material, the same material with the polycrystalline structure or pure single crystal structure, then their elastic modulus and tensile strength will be different. So these are the things we have seen today, like initial syllabus. With the syllabus, initial ideas like elasticity and the stress strain diagram and the factors affecting elastic modulus and tensile strength, those things and all we have seen here. If there is any doubt, you can post it in this video. I like to thank you all. Thank you.